All right, now we'll do some examples, or we'll do one example of an acid-base reaction. We'll start off really easy. We'll start off with a strong acid, HCl, plus a weak plus a strong base, NaOH. And so if we draw the principal species in solution for each of these, we don't have to think about whether or not these are soluble. It says they're soluble. They're strong acid, strong base, so we know they dissociate. Or I should say ionize in the case of acid. So the HCl is going to yield H plus in solution and Cl minus. The NaOH is going to yield Na plus in solution and OH minus. So now, just like with precipitation reactions, we have to figure out what's going to react. Well, it's the cation reacting with the other anion, so H plus and OH, and then the opposite will happen here as well. So what do we, well, let's write out our equation first, or our reactants. So we have H plus aqueous plus Cl minus aqueous giving, or plus Na plus aqueous plus OH minus aqueous. So we have to figure out what we get here. Well, let's take a look. H plus and OH minus. Okay, what do they form? Well, in some classes you might have been told it's okay to write HOH, but not in this class. HOH, if you can't figure out that HOH is just H2O, I don't know what to tell you. Because I once saw a video about a guy, this is a news program where he told the news reporters that he had developed a new fuel that was going to revolutionize car travel and everything. It was called HOH gas. Yep, HOH gas, which is just water. He discovered water. And the news people were all excited because he was apparently a genius. And they were not. Anyway, so HOH is H2O. So that's what you get every time when you combine H plus and OH minus. You get water. And no matter where the H plus and the OH are, you get water. Okay? They always find each other if they are in solution together. Remember, we're combining these, obviously. So what's left over is Na and Cl, which would be NaCl, the compound NaCl sodium chloride, but it's soluble in water, so we write it as ions, of course. So the products for this are H2O liquid plus Na plus aqueous plus Cl minus aqueous. All right, and now all we have to do is go through and cross out our spectator ions. Let's use a highlighter for that. So our spectator ions here are Cl minus and Na plus. And if we write down everything that's left, that's going to be our net ionic equation, obviously. And so we get H plus aqueous plus OH minus aqueous yielding H2O liquid. And like I said, that is our net ionic equation. So that's our final answer. And I'll tell you one more thing about this one that you probably want to know. This is always the net ionic equation for strong acid plus strong base. Always the net ionic equation for strong acid plus strong base.